Hi everyone, and welcome to a quick session about infrastructure as code security. My name is Barak Schoster. I'm a CTO and co-founder at Bridgecrew, a cloud security startup that has both a very large open source projects and a great platform that solves some of the issues that we'll talk about today and about cloud misconfigs. If any of those open source projects around AWS security, Terraform CloudFormation, Kubernetes, and GCP security are in interest for you, please feel free to reach out at Twitter. It's Barak Schoster, common case. All right, so let's take a step back and think, what was infrastructure security a few years ago? So back in the 90s, it probably has been these old firewalls with knobs and switches, and people that were responsible on the security of the perimeter were actually the people that brought it into the data center, took the heavyweight server, plugged it in, and the way for them to manage security is actually to play with it. One generation after that came the management console of the firewall that gave the IT professionals an idea of how to manage the network and how to manage the different configurations of it. And it was really centralized within the IT or security team to hold the keys to the kingdom, which is the data center. A few years after, or nowadays, or at the past 2 or 3 years, we are not seeing those kind of infrastructure as much as we've seen in the past. We're not seeing those centralized team that manages security within IT boxes. What we are seeing is a decentralized solution of managing firewalls, for example, or infrastructure generally, using API calls, like the security groups or firewall manager of the AWS cloud. And this is really a huge transformation because instead of doing a manual work with a dedicated node switches or dashboards, we can now stand up a new firewall with just 7 lines of code. So over here we have an example of a Terraform block. Terraform is an infrastructure as code language that helps us define a firewall with a port of TLS SSL open to the entire wall, which is usually safe for web servers. And it doesn't look the same like it used to be. So Terraform is one of those infrastructure as code languages that gives us the flexibility of creating new resources by the throughput that we have on our business. It is platform agnostic. It has the ability to manage a state and keep history and track the changes in your environment, and essentially version control your infrastructure, your architecture using code. And this has a lot of upsides in terms of productivity. You can now move some of the workload that was only centralized in the security team into the developers teams and application teams and cloud engineering teams. And what we're seeing today is more and more infrastructure as code languages exists for different use cases. So we have Terraform for infrastructure provisioning. We have CloudFormation and ARM that does exactly that, but only for AWS or Azure. We have Kubernetes, which is a great orchestration framework for containers, Ansible for OS management, serverless for Lambda functions and Azure functions, and Puppet for some bare metal configuration changes. And it is really great because you can stand up a whole data center, a whole production environment in just a few lines of code and minutes of deployments. It lets us move much faster and be centralized around business logic and really have a great solution to how to scale that business logic when there is a need. The issue with these configuration as code frameworks is that it might bring with them some unrecognized risk. And it's not because those frameworks creates a risk, it's because people are writing more and more code, more and more configurations, and they are not always aware of misconfigurations that are inside those codes. So where would you find those misconfigs in those infrastructure frameworks? Probably at the open source, or even in internal GitHub repositories or the Terraform registries or blog posts. People are writing these boilerplate templates to provision a new web server, for example, or a new database, but they often might forget, maybe because of lack of knowledge, maybe because they didn't pay attention or didn't have the capacity to review that code. They are not putting the best practices of security into those configuration frameworks. So let's take a look on a small research that we've done inside Bridgecrew. So in Bridgecrew, we've scanned randomly 1,800 different Terraform modules from the open source. And what we found is that 48% of those were misconfigured, meaning had some kind of security risks, like unencrypted databases, open ports to the world, and we will see some of those examples. While 52 were configured correctly, it's still a lot of misconfigured modules in the open source. And how many downloads did those misconfigured modules had? Over 10 million. That means that over time, we had 10 million provisioned resources in the public clouds that were misconfigured at some point in time. While it does not really mean that those specifically were necessarily exploitable, it is still a huge risk to bring into your cloud environment, either when using open source modules or creating your own. And what are the kinds of misconfigurations are? So most of them, and the top one issue is the lack of logging and auditing. And that means that your security team really lacks the visibility to the infrastructure that is in the cloud. Backup and recovery is really a reliability issue of what would happen in case something bad happens. And encryption, obviously, nowadays it's really easy to encrypt each and every resource with managed services like AWS KMS and CMK, or even solutions like HashiCorp's Vault. It really is easy and quite cheap to manage encryption of data, but we are not seeing that implemented as a default on each and every open source model. And there are obviously issues with Kubernetes, networking, and overprivileged IAM roles. And how does that look over time? What we're seeing here is that every few months, the pace of contributing new modules is going up and up. And this is great. It gives us as developers more and more power and more pre-made cookbooks of how to create new infrastructure. The issue with that is that over time, the number of misconfigured modules is also rising in a huge pace. So what we see here is that we had like a very few new modules contributed every month. And at the passing month, the pace is like a hockey stick. And this is June, which is still not completed. And what happened during COVID? We had a huge spike, probably because of productivity and everybody are at home. We had a huge spike of new misconfigured modules in the open source. So how can we solve those misconfigurations, detect them, and fix them? This is why we started Bridgecrew. Bridgecrew can track every change in your infrastructure code, from the change request that you've created in your GitHub or GitLab account, to a scan, a fix, and then only after the fix is being applied or a scan is being approved and not rejected due to security reasons, a new set of resources can be provisioned into your cloud environment. From there, Bridgecrew will keep and continue to monitor your production environment for any configuration changes that are either being done using infrastructure code or manually by an admin that has access directly to that AWS console. How does that look like on the developer side? Here we can see a pull request that has an annotation that Bridgecrew made a Bridgecrew action on GitHub on the security group, and it has the annotation that port 22 means SSH is open to the entire world, and that should be actually fixed. And the pull request of this developer that created a new web server in Terraform have failed due to security checks that did not pass. How can we solve that at scale? So let's think that we have those thousands of lines of infrastructure code. What Bridgecrew can help with is automated pull request that detects bad configurations and bad practices and pushes fixes to your GitHub with new pull requests that fixes this infrastructure. So over here you can see an DB instance that didn't have encryption turned on, and it's just getting turned on automatically and opens up a new pull request. So Bridgecrew is really about detection and fix of infrastructure in the public clouds. If you'd like to learn more about Bridgecrew, you can start for free at bridgecrew.io. If you'd like to take a look on our open source tools that are about static analysis of infrastructure code and runtime analysis of infrastructure code, please visit our GitHub page at github.com/bridgecrew.io, and you can read more about it at docs.bridgecrew.io. If you have any other questions, please feel free to direct message me at Twitter. It's Barak Schoster, camel case. Thank you.